This should be a level 2 question. P is an expression that is been given here and we have to find the value of P. Now looking at the question, P is 1 upon 1 factorial plus 2 factorial plus 1 upon 2 factorial plus 3 factorial, so on till 1 upon n factorial plus 10 factorial. So I can say that P is equal to nothing but summation of 1 upon n factorial plus n plus 1 factorial, where n ranges from 1 to 9. So the nth term of P, that is what I have defined it as, is 1 upon n factorial plus n plus 1 factorial. So now if I take n factorial common, this becomes 1 plus n plus 1, that is 1 upon n factorial into n plus 2. Now n factorial into n plus 2. Now if I multiply that by n plus 1, it will become n factorial into n plus 1 into n plus 2, which will become n plus 2 factorial. So I would multiply the numerator and denominator by n plus 1, and we end up at n plus 1 by n plus 2 factorial. Now n plus 1 can be written as n plus 2 minus 1 on n plus 2 factorial. So that becomes n plus 2 upon n plus 2 factorial, which is 1 upon n plus 1 factorial minus 1 upon n plus 2 factorial. Now the objective to do this was simple. Only if I get a minus will I be able to subtract terms. And how do I know that I need to get a minus? If you look at the options, all options have a minus sign in them. So what I get from here is, if each term can be expressed as 1 upon n plus 1 factorial minus 1 upon n plus 2 factorial, P becomes, so the first term would become, when n is 1, would become 1 upon 2 factorial minus 1 upon 3 factorial. Similarly, the second term would become 1 upon 3 factorial minus 1 upon 4 factorial. Third term 1 upon 4 factorial minus 1 upon 5 factorial. And the last term would become 1 upon 10 factorial minus 1 upon 11 factorial. If you look at this, second and third term cancel out, fourth and fifth, sixth and seventh, so on and so forth, and the n minus 1th term, that is the second last term, would also cancel out with the third last term. So all we'll be left with is 1 by 2 factorial minus 1 upon 11 factorial. Thus the answer would be option A.